Let's introduce the concept of a service. After pods and deployments, services are maybe the most important Kubernetes objects out there. In order to understand the need for services, let's go back to the beginning. As we've said a million times before, a pod is the atomic unit of deployment in Kubernetes. One or more containers will run inside a pod. A pod will be managed usually by some higher level abstraction such as a replica set, which is responsible for bringing up and taking down pods. Replica sets in turn tend to be controlled by even higher level abstractions such as deployments. In all of this, one crucial aspect of the pod needs to be recognized, and that is the ephemeral nature of the IP addresses of the pod. We've seen how within a pod spec, a container needs to expose a certain port. On that port, it will accept client requests. But that's not going to help much if the IP address of the pod is changing all the time. When replica sets or replication controllers take down pods and bring up new pods, all of these IP addresses associated with the pods are changing. The question that arises then is, how is a client to know where a particular pod or a container is to be accessed? And it is precisely in order to answer this question that the service object comes into play. A service object is a Kubernetes object. This is an abstraction which defines a logical set of pods as well as a stable network interface for these pods, consisting of a stable IP address, DNS name, and a port. Notice how we called a service a logical set of pods. This logical grouping of pods is achieved by using, well, you guessed it, label selectors. A service can be associated with any logical set of backend pods. While defining the specification of the service, we've got to create a label selector. That label selector will then go ahead and apply to all pods at the backend which have the same labels as our label selector. And in this way, we once again get a loose coupling between services and pods at the backend. In addition to the label selector of the service object, which defines the loose coupling between services and pods, there is also a dynamic mechanism. This is achieved through an endpoint API object. This dynamic mechanism allows new pods which join the Kubernetes cluster or which newly come into existence to be correctly associated with services which have the correct label selector clause. So we can think of this endpoint object as something that is associated with each service. This endpoint object can be thought of as a dynamic list of all of the pods that match the services label selector at any point in time. Kubernetes takes the responsibility of updating this endpoint object by constantly evaluating the services label selector versus all of the pods in the cluster. As new pods get added to the cluster or old pods disappear, this dynamic list, which is maintained inside the endpoint object, is going to be updated as well. The endpoint object keeps the internal state of the cluster up to date, but for applications which are accessing our service from outside Kubernetes, in other words, for non-native Kubernetes apps, there is yet another mechanism. This is a virtual IP based access point to each service. Cast your mind's eye back to our conversation about the control plane in Kubernetes. We had said that there are certain components which run on each node. Those three components were the kubelet, the kube proxy, and the container engine. We really weren't very clear about what exactly the kube proxy did. Well, this is where we get the answer to that question. The kube proxy serves as an entry point. It relays incoming requests from outside the Kubernetes cluster back into the correct service. And in this way, the kube proxies help to implement this virtual IP based access points to the services. In this way, external clients or non-native Kubernetes apps can hit any node in our cluster as long as they do so on the correct port. The correct internal relaying and wiring will take place so that the kube proxy transmits the incoming client request to the appropriate service. And so again, service objects in Kubernetes help to provide a standard, stable network interface to groups of pods at the backend. For access to services from within the cluster, the endpoint object serves as a dynamic list of pods which are currently associated with the service. For access to the service from outside the cluster or from non-native Kubernetes apps, a virtual IP based system is implemented using the kube proxy which runs on each node of the cluster.